Geometry, Unit 13, Sections 4 and 5. Section 4 is circle with parallel lines, and Section 5 is angles formed by tangents. So we're going to discuss both of these concepts in this video. So the key for parallel lines is this one phrase right here, and that's simply that parallel lines in a circle create congruent interior arcs. That's it. So, for example, given BC is parallel to AOD. Now, when you have two parallel lines in a circle, what you get is two interior arcs. The arc inside the parallel lines, kind of like alternate interiors, so the concept of interior versus exterior, interiors between them. So we have arc AB is interior, the parallel lines, and so is arc CD. And because these lines are parallel, what that means is that AB is congruent to CD. Arc AB is congruent to arc CD because they are the interior arcs of two parallel lines. And so if AB is 35, that means that CD is 35. And let's see here. What are we asked to find? We're asked to find arc BC. Well, so that's interesting, but we have a diameter here. AOD is a diameter, so that means that this whole thing up here is a total of 180. And if I have 35, 35, these combine to be 70. And if this whole thing is 180 and I got 70 between these two, that means that BC has to be 110 degrees. And angle CBD is a inscribed angle on the circle here, and its arc is CD. It's going to be half of that 35. Half of 35, let's see, that would be what? 17.5 degrees, I believe. Okay, let's try another one. Given BC is parallel to AD. All right, so right there, that means that arc AB and CD are going to be congruent. They're the interior arcs of those two parallel lines. And, sometimes I just jump right into the problem without even seeing what it's asking for here, because things stand out to me. I'm given this angle of 70 degrees. I see it's at the center, so it's a central angle. That means that this arc is 70 degrees. And that's one of my interior arcs. That means my other interior arc is 70 degrees. Since this up here is 110, together that's 140. That's a total of 240 degrees I have. I only have one arc remaining, so if I subtract that 240 from 360, I'm left with 120 degrees must be arc AD. And that's what I wanted there, and that's what I wanted there. So you could take a look at what they're asking for, but when you see things like central angles and parallel, you kind of know what they want you to find before you even read it sometimes. So you should always read the question, of course. But that's really it for parallel lines. You look for those congruent interior arcs. A lot of times they'll kind of give you one, but you need the other, but you know they're congruent. Of course, we look for diameters, we look for central angles, we look for inscribed angles, all that good stuff. Because we're dealing with parallel, you know you're going to see a concept of alternate interior come up at some point. Like this angle is also 17.5 degrees because you see that Z pattern, stuff like that. All right, and then how about tangent angles, we call them. Tangent angle is an angle whose vertex is on the circle and formed by a tangent. So this right here, this is an example of a tangent angle. It's got chord ED and tangent EG, meeting at point E to form angle DEG. And so this angle is not really inside the circle, and it's not completely outside. It's kind of part in, part out. So, we can't call it inscribed because it's not completely in the circle. But it has the same relationship as an inscribed angle. The degree measure of a tangent angle is half the measure of its intercepted arc, and the arc is double the measure of its tangent angle. This is the same relationship as an inscribed angle. So it's not called an inscribed angle. It's a pretty terrible E in there. Because it's not completely in the circle, like this angle is completely in the circle, that's called inscribed. But what they have in common is the vertex is both on the circle and it has that half double relationship. So basically, anytime you have an angle that the vertex is on the circle, who cares if it's called inscribed or if it's called tangent? Its relationship is it's half the arc inside of it. So the difference, the other thing there is like, for an inscribed, so typically for the angles we've seen, it's, the arc is connecting the two endpoints. That's not what you see here. That we see for when it comes to tangent angles, let me highlight the tangent angle here. Vertex is on the circle. The arc is not going from like endpoint to endpoint of the angle. The arc is actually like kind of inside the angle, like that. But it is the same thing as if it was like that. It's half of the arc inside of it, just as this inscribed angle is half of the arc inside of it. It's just kind of located in a different spot. So you could just kind of remember a blanket statement that when the vertex is on the circle, it's half the arc inside, regardless of how that arc is inside, whether it's end to end or kind of in it like this. So angle DEG is half of the arc inside of it, half of arc. That's 98 degrees. Half of that would be 49 degrees. Half of 98. Let's try one more quick example, and then we're done here. This one's a short. Given major arc AD is 300 degrees. Remember, this would be considered minor arc AD versus major arc AD. Find the measure of angle ADE. So here's a tangent angle. I see it's a tangent angle because it's formed by a tangent, but it's also its vertex is on the circle. Now this tangent angle is half the arc inside of it. 300 is not the arc that's inside of it. Minor arc AD is the arc inside of it. And one way to solve this problem is to find minor arc AD. If major arc is 300, minor arc must be 60, because together that is a full circle 360 degrees. And our angle is half of the arc inside, so that would make that 30 degrees. The other option was that there is a second tangent angle here. This, not just ADE, but ADG is also considered a tangent angle. And this is half of its arc, and its arc is major arc AD. So half of 300 is 150, and then I know these two angles together are going to be supplementary. So as with a lot of these problems where it's find the angle or arc or stuff like that, there's a lot of different paths you can take to get to that same answer. As long as you know the key relationships like interior arcs or parallel lines are congruent, or when it's on the circle, it's half the arc. When the angle's at the center, it equals the arc, things like that. If you know those rules and you're careful with your supplementary, all the arcs add to 360 type of stuff, it's really, really not too bad. And you may go a different path than another student, but still end in the same correct location. Okay, so that's those are your inscribed, those are your tangent angles and your circles with parallel lines. That's it. See ya. See ya.